Hello, everybody. Today, I'm going to talk about GCFs of monomials. My name is Miss Wiley, and I hope you enjoy this lesson. All right, so today, let's recall first finding a GCF of a number. Now, to find a GCF of a number, you could essentially look at these two numbers and think about what is the biggest number that I can divide both these numbers by and get a whole number value, right? So we know that both of these values could be divided by 2, right? But is that the biggest number that goes into both of those? No, the answer to that is no. That's something that we definitely know. So let's think about a bigger number that goes into both of them, like maybe a 4. Right? And a way that you could easily check that that's the GCF is actually do that division. When I divide 16 divided by 4 and 28 divided by 4, I get a 4 and a 7. And the result of that division, you can see 4 and 7 have nothing more in common, right? Now, if we would have done this, what I was talking about before, divide by 2, I think the GCF is 2. Well, if you divide 16 by 2, you get 8 by 28 by 2, you get 14. 8 and 14 still have something in common. So you know you found a factor of 16 and 28, but not necessarily the greatest common factor, right? And so I could say, oh, well, 8 and 14 have a 2 in common, right? Again, and that gives me a 4 and a 7. So I can see there that, they had a 2 in common, and again, they had another 2 in common. 2 times 2 equals 4, which is the same thing that we thought about over here when we were dividing both 16 and 28 by 4. So just a little bit of number sense of figuring out how to find the GCF. Now, you can, on each of these, take the time and do your prime factorization of them. So I'll just do that up here because I'm sort of running out of room. 16 is 2 times 2 times 2 times 2, right? 28 is 2 times 2 times 7. And I can see that the most they have in common is 2 2's. So again, that means that our GCF is 4. So there's a lot of different ways that you can come up with finding the GCF. Sometimes it's just a matter of thinking about the values that go into 16 and 28. When the numbers are larger, sometimes you have to divide multiple times to figure out what is the biggest number that goes into both of them, or you can use the prime factorization like I showed here. Let's change the problem up a little bit, and let's involve some variables here. So not only are we having to deal with the GCF of numbers, but we also now have some variables here. So oftentimes when there's numbers or coefficients and variables involved, I often think of it separately. So think about the GCF of the numbers, and then think about the GCF of the variables. And actually, the GCF of a variable is it's very simple. So let's talk about 24, 48, and 36. So when I think about, and this is a little bit of side work here, 24, 48, 36, think about it without the variables, right? So if the variables are sort of tripping you up, write them off to the side and think about it. I know that in each of these numbers, a 6 goes into them, right? So let's see if that's the GCF, meaning that if I divide each of these numbers by 6, the numbers that I get as a result of that division should not have anything more in common. So I have a 4, an 8, and a 6. Well, look at that. You can see here that 4, 8, and 6, those have a number in common too. What number do they have in common? Right, they have a 2. So I could divide each of those by 2. Dividing each of those by 2 would give me a 2, a 4, and a 3. And you can see that the result of that division gives me 3 numbers that don't have any more numbers in common other than the number 1. So that means that my GCF is the product of what I divided here and what I divided here. So I divided by 6 in the first one, and then I divided by 2 in the other one. So the GCF of the numbers only is 6 times 2, which equals 12, right? So that's my GCF, but that's the GCF of just my numbers. So I know now that my GCF is going to be a 12 for my numbers. Let's talk about the variables. So in the first term, I have x to the fourth. In the second term, I have x to the second. And in the third term, I have x to the third. Now, if we expand those, sort of like we do with a prime factorization, we know that x to the fourth power is x times x times x times x. We know that x squared is x times x. We know that x cubed is x times x times x. And you can see that the most x's they have in common are 2 of them. So x times x is x squared. So the GCF, I'll write that here, the GCF of the variables only is x times x, which is x to the second power. So together, the GCF of our monomials listed in the original problem is going to be the product of the GCF of the numbers and the GCF of the variables. So the GCF is 12x squared. And that is your final answer. Yay! So I have one here, another one here. This one's a little different because it has 2 variables. Okay, so I want you to take a minute, pause this video, and think about what is the GCF of 27 and 9. Okay, you should have come up with the GCF of the numbers 27 and 9 is 9. That is the biggest number that goes into both of them. So now let's talk about the variables. Now for the variables, we have A's and we have B's. So you kind of have to think of these things separately. You need to think about what's the GCF of the A's, what's the GCF of the B's. Now you don't need to write out all of this work. This is more about like what you are thinking. So I'll make it like a think bubble here. Right? This is sort of what your brain is thinking about in your head. Maybe you have to write it down, but maybe you don't, right? So the GCF of the A's, let's talk about that over here. We have an A squared and we have an A. A squared is A times A. An A doesn't expand, it's just A. So the most A's that it has in common is 1A. So the GCF of the A's is A, right? And now let's look at the B's. For the B's, I have a B and I have a B squared. Talking about the B's in each of the term, right? Each of the terms that we have there. So we have a B doesn't expand, B squared is B times B. So then from there, we can see they have 1B in common. So that means that our GCF is going to be the product of each of these GCFs that I found. So my GCF for this problem is 9AB. Okay? Now to check that, what you could do is you could take, and let me move this problem down. You could take that original problem, that 27a squared b and the 9ab squared. If you divide each of those terms by your GCF, you should get results that are not fractions and don't have negative exponents. So 27 divided by 9 is 3. A squared divided by a to the first. Remember, subtract your exponents would give me a to the first. B over b, that would cancel out. It would be b to the 0, but b to the 0 is just 1. so that goes away. 9 divided by 9 is 1. You don't have to write the 1. A divided by A, also 1. So basically this cancels out because they're 1, right? So think of them as 1. And then b squared divided by b to the first technically is b to the first because we subtract the exponents. So you can see that when I divide by the GCF, I get results that not only are not fractions, but they also don't have negative exponents. So that's sort of like, this is sort of like your check if you wanted to check. And again, you can do that check in your head. So I have one more example here for you to try. So I want you to pause this video and I want you to take a moment and try this problem on your own. Okay, hope you paused that video to give this one a try. The GCF of these three terms is going to be a 2 and an x, 2x. Now you might be asking, why is the GCF not 2xy? Well, if you look at the three terms, there's only two terms that have a y in common. In order for a y to be part of the GCF, there would have to be a y right there for that middle term, and it doesn't have that. So since it doesn't have that, we cannot include y as our GCF. I hope this video helped you out. Please take a moment and click like on this video if you like it and subscribe to my page. I'll be posting more videos as the weeks go by.